Hello, this is Mr. Brooks, and welcome to Lesson 4.3, Triangles Congruence by ASA and Angle Side. In this lesson, we're going to prove two triangles congruent using ASA postulate and the AAS theorem. Our first postulate in section 4.3 is the angle-side-angle postulate, which states, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. We will simply refer to this postulate as angle, side, angle, ASA. In example number 1, we are asked which triangle is congruent to triangle CAT by the angle, side, angle postulate, by ASA. Please pause the video while you try to figure this out. Hopefully you will agree it is the middle triangle, triangle DOG, dog. However, you cannot, if we call the triangle on the left triangle CAT, you cannot call the triangle in the middle triangle DOG. You have to say what angle corresponds to C, which is G, which one corresponds to A, which is D, angle D, and then which one corresponds to T, which is O. So if we call the triangle left triangle CAT, you must name the one in the middle triangle GDO. Hopefully you see the triangle in the lower right, triangle FIN, is not the included side between the two angles. That's why we cannot get that triangle congruent to the other two, because the side is not included between the two angles. Now let's look at example 2. We're trying to prove the two outside triangles of the lacrosse goal are congruent. We're given angle CAB is congruent, angle CAB is congruent to angle DAE. Those angles are congruent. We're also given segment AB is congruent to segment AE. So those two segments are congruent. And we're given that angle B and angle E are right angles. How are we going to prove the triangle is congruent? Well, first thing we're going to say is angle ABC is congruent to angle AED because all right angles are congruent. And then we can say the triangles are congruent by angle, side, angle. Now let's look at quick check number 2. We're trying to prove these two triangles are congruent. It's given that segment MN is congruent to segment PN, and angle M is congruent to angle P. Those two things are already marked. Pause the video while you try to figure out how you're going to get these two triangles congruent. Hopefully you will agree triangle LMN right here is congruent to triangle ONP right here. Why? Vertical angle theorem. Now again, make sure that the L corresponds with the O and the M with the P. If you put the M first, the P's got to go first. If you put the M last, the P's got to go last. And now we can state what we were trying to prove. That triangle, let me name it a different way. Let's call it NLM. If I call the triangle on the left triangle NLM, how must you name the one on the right? You better call it triangle NOP. Why are those triangles congruent? Angle. Oops, that was wrong. Sorry. Angle, side, angle. Our first triangle congruence theorem, the others were postulates. Our first triangle congruence theorem is going to be angle, angle, side, AAS, which states if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. Let's look at a flow proof of this theorem. We're given two angles congruent and the non-included side in both triangles. How could we get the triangles congruent? Well, if we can say that angle A is congruent to angle X and angle B is congruent to angle Y, then we're going to be able to say angle Z is congruent to angle C. Why is that? Because two angles of one triangle are congruent to two angles of another triangle, then your third pair of angles must also be congruent. Now we can say the triangles are congruent by angle side angle. Now let's look at example 3 and quick check number 3 at the same time. We're trying to prove the two triangles congruent. It's given that angle S is congruent to angle Q and that segment RP bisects angle SRQ. Pause the video while you try to figure out step 2. Step 2 should be angle PRS is congruent to angle PRQ by definition of an angle bisector. They should not have had that marked in the figure at the beginning because that was not given. It told you that PR bisects angle SRQ, but it did not tell you those two angles are congruent. You need to have that as a separate step in your proof. Now pause the video while you try to figure out step 3. Hopefully next you're going to say segment PR is congruent to segment PR. Now please pause the video while you try to come up with the reason for step 3. Hopefully you agree that is a reflexive property, and now we can say that the two triangles are congruent. Triangle, I'll call it triangle RSP, and if I call the one on the left RSP, how must you name the one on the right? You better call it RQP. And why is that? Angle, angle, side. Now let's look at example 4 and see if we can come up with how to prove these two triangles congruent. What's given is that XQ is parallel to TR and that XR bisects QT. Well, how would we be able to get angle Q up here congruent to angle T down here? Well, what's going to be your reason for step 2? Please pause the video while you try to figure this out. Hopefully you came up with if parallel lines, then alternate interior angles are congruent. And the same thing can be said about angle X and angle R. If parallel lines, then alternate interior angles are congruent. Now, if XR bisects QT, why can we say that QM right here is going to be congruent to TM right here? Well, that would be by definition of a segment bisector. They told us that XR bisects QT, so those two segments must be the same, and now we can say triangles are congruent by angle, angle, side. Quick check number 4 asks us to prove these same two triangles congruent using angle, side angle. If we are trying to prove these two triangles congruent by angle, side angle, and we're given that the top and the bottom are parallel, first we would say, we could say angle Q is congruent to angle T by if parallel lines and alternate interior angles are congruent. It's also given that XR bisects QT, so we can say that segment QM is congruent to segment TM by definition of a segment bisector. And instead of saying angle X is congruent to angle R, this time we're going to say angle XMQ is congruent to angle RMT by vertical angle theorem. And now hopefully you can see these two triangles are congruent by angle, side angle. This concludes lesson 4.3.